Greetings and welcome to lecture 8.5, Completing the Square. So we're going to continue solving quadratic equations by the method of completing the square. So here we go. Here's a definition. Individual terms of trinomial. The first term of the trinomial is called the quadratic term. The middle term is called the linear term, and the last term is called the constant term. Consider the trinomial of x squared plus 4x plus 4. We can factor that to x plus 2 squared. X squared plus 6x plus 9, we can factor to x plus 3 squared. X squared minus 8x plus 16, we can factor that to x minus 4 quantity squared. X squared minus 10x plus 25 will give us the quantity x minus 5 quantity squared. And x squared plus 12x plus 36 will give us x plus 6 squared. Here's a couple things that we really should take note of. First, the coefficient of the quadratic term is 1. So the quadratic term is the first term of the trinomial. All of these have the quadratic term coefficient of 1. Secondly, the constant term is the square of 1/2 the linear term. Okay, so that 1/2 of the linear term here is 6, and then the last number is squared. So 6 squared is 36, and that gives us a perfect square. Let's practice doing this. X squared minus 14x. So if I wanted to find what my perfect square will be, I'm going to take half, divide by 2, negative 14, and then square it. Well, it's going to be 49, because negative 14 divided by 2 is negative 7. Negative 7 squared is 49. So that would give us x squared minus 14x plus 49 will give us x minus 7 quantity squared. What about x squared plus 20x? Again, I'm going to take that middle term, divide it in half, divided by 2. That gives me 10. The square of 10 is 100. So x squared plus 20x plus 100 will give us x plus 10 quantity squared. X squared plus 5, I'm again going to divide 5 by half, by 2. That equals 5 halves. The square of 5 halves is 25 fourths. So x squared plus 5x plus 25 fourths will give us x plus 5 halves quantity squared. How does all of that help us? Well, we can solve a quadratic equation by using this method of completing the square. So let's solve x squared minus 4x plus 3 equals 0 by completing the square method. So the first thing I want to do is I want to move the 3 out of the way. The 3's sitting there, I get that. But let's move it out of the way so we can complete the square of the quadratic term, the linear term, right? Okay, so the first thing I'm going to do is take negative 4, divide it in half. That's negative 2. Square it. Gives me 4. I'm going to add 4 to both sides of the equation. As long as I add the same value to each side, I'm not messing up what the solution set is going to be. Now that I've added 4 to both sides, it's going to give me x minus 2 quantity squared equals 1. I'm going to take the square root of both sides. Square root of a square gives me x minus 2, and the square root of 1 is going to give me plus or minus 1. Now I have x minus 2 equals plus or minus 1. Those are two equations that I can solve. X minus 2 equals 1 and x minus 2 equals negative 1. Add 2 to both sides, x equals 3. Add 2 to both sides, x equals 1. Now, you may have noticed that in the very beginning you could have factored x squared minus 4x plus 3. That would give us x minus 3 and x minus 1. we solve it, we get down to the same problem of x equals 3 and x equals 1. It was a simple problem. We could have used a different method, but to start using this completing the square, it's nice to start off with a simple problem. But let's get a little bit more complex. Let's solve 3x squared plus 24x minus 27 equals 0 by completing the square. The first thing I want is I want a 1 in front of that leading coefficient of the quadratic term. So I'm going to divide, I'm going to factor out the 3 and then divide by 3. That will result in x squared plus 8x minus 9 equals 0. You might think, oh, I can factor this. You can. I understand you can factor this. But let's use the completing square method. I'm going to move the 9 off to the right-hand side, leaving me a little bit of space to complete the square. I'm going to divide 8 by 2 and then square it to fill in the blank. When I do that, 8 divided by 2 is 4, 4 squared is 16. I'm going to add 16 to both sides. Plus 16 plus 16. That leaves me with x plus 4 squared equals 25. Take the square root of both sides, leaving me with x squared, x plus 4 equals plus or minus 5. X plus 4 equals 5, x plus 4 equals negative 5. Subtract 4 from both sides, I get x equals 1. Subtract 4 from both sides, x equals negative 9. Now yes, when you get further into this course, you'll want to analyze your quadratic equation, see which method will work best for the situation that you're in. But right now, we're going to practice completing squares. Here's strategy for solving quadratic equations by completing the squares. First thing, you want to put the equation in the form of a x squared plus bx equals c. If the coefficient of the quadratic term is not 1, then divide each of the terms by its coefficient. We want to add the square of half of the coefficient of the linear term to both sides of the equation. That means b divided by 2 squared will get you that term. We want to write the left-hand side as a binomial square and apply the square root property to solve. 4 steps. Okay. Using the 4 steps, we're going to solve y squared minus 4y equals 0. By factoring, I can factor out a y, leaving me y minus 4. So I'll set each to 0. So I'm going to get y equals 0 and y equals 4. By completing the square, I'm going to take the negative 4, divide by 2, square it, and that's what I'm going to add to both sides. I get y squared minus 4y plus 4 equals 4. Now it's y minus 2 quantity squared equals 4. Take the square root of both sides, leaving me with y minus 2 equals plus or minus 2. The two equations are going to be y minus 2 equals 2, y minus 2 equals negative 2. Subtract 2 from both sides, or pardon me, add 2 to both sides, I get y equals 4. Add 2 to both sides, I get y equals 0. Same solution, different method. Let's take another problem and complete the square to solve it. X squared plus 5x minus 2. First step, I'm going to move the 2 over to the right-hand side to leave room to complete the square. Completing the square is going to be 5 divided by 2, which is 5 halves, and square of 5 halves is 25 fourths. Yes, I know it's a fraction, but we can work with fractions here. Add 25 fourths to both sides. That will give me the binomial square of x plus 5 halves equal 33 fourths. Square root, take the square root of both sides. That leaves x squared plus 5 quantity squared to the square root, and the square root of 33 fourths, giving me x plus 5 halves plus or minus the square root of 33 over 2. Now how did I get the 2? The square root of 4 is 2. Subtract, break it apart, and subtract 5/2 from both sides. And that will give me x equals -5 plus the square root of 33 all over 2. Or x equals -5 minus the square root of 33 over 2. Now you can see you would not have been able to factor this problem, but we do have a solution. So that's it for this video. So until next time, be seeing you.